Welcome back, everyone. Today we're celebrating our 100 subscriber milestone on the channel. I'm so happy that you guys are enjoying this content. In this episode, I'm going to be working on a brand new cross slide from my 1925 Southbend 9-inch junior lathe. Off camera, I prepared a billet which was machined parallel and down to the nominal dimensions to suit this project. Here, I'm dialing in the part on the mill and setting up my DRO. As you can see, I'm bringing up the drawing that I made in Siemens Solid Edge. I used this drawing to prototype a few 3D prints on my Creality Ender 3 Plus printer in PLA, and now we'll use this to guide our machining operations on this part. On the drawing, I've highlighted three really important numbers. One is the width of the overall piece at 3.20, the width of the dovetail, which is just below that at 2.125, and finally the height of our dovetail at 0.339. All of these dovetails will be cut at 60 degrees. Another important measurement that we're missing is the rough opening for the dovetail. It's implied through the measurements here at the bottom, which are there to help me machine this part on the mill. That 1.805 is actually the inside side-to-side distance that I will be measuring to. The next thing I want to draw your attention to is on the right side of the drawing, measuring the distance from the bottom of the cross slide to the top of the dovetail at 0.401. I ended up only making this out to be about 0.352 by the time we're done. The purpose of that was to have a nice tight fit over the male dovetail on the saddle and to not leave room for chips to get in between the two parts. And the last thing to look at are these two round reliefs that I had in the drawing up here in the corner of the dovetails. These were great when I was just 3D printing out the part, just to do the test fits, but in reality, there's no possible way of machining these in my shop today. These parts are 6 inches long, and those are 1/8 inch round holes that run down the length that make it impossible for me to machine. I also do not have a radius side cutter to deploy, so I declined to leave those in our final part. Alright, so we're back at the mill. I've got a 1/2 inch solid carbide end mill chucked up in a 1/2 inch collet. I'm using the paper trick here to get close to the top of the piece and set my quill DRO. That piece of paper was about 12 thousandths thick, so I knew I had about 12 thousandths to go, and I think in reality it was maybe another 2 thou before I actually touched off. So I touched off, dialed in a 50 thousandths cut, just came in here a little bit, and we'll do a quick measurement to make sure we're in the right place. You can see here I'm using the tip of a file just to knock those burrs off the cut. Unfortunately, we had lost a lot of the original audio from the videos for most of these clips, so I'm going to voice over almost the whole thing. So I apologize if that gets annoying. You're just going to have to listen to me narrate this, maybe somewhat in arrears from what I normally would do. So hopefully I can keep up with you guys and keep up with the video. So measurement looks good. If you remember from the drawing, this measurement should be 0.660. I backed that off a little bit and made it about 665 or 670. I don't remember which one it was, but I left myself 5 or 10 thou there to come back and do a finished cut. Alright, so here we go with our depth of cut set to 50 thousandths. I believe the table or travel speed was 2.5 to 3.5 inches per minute, depending on which cut I was in. Keeping this pretty slow. This carbide cutter is really great, but I also don't want to break it. They're somewhat pricey. Measurements look good, so we're going to go ahead and send it back. So my plan here is actually to center cut this all the way down in a groove, get it down to the depth that I'm looking for. Like I said before, about 350 or 352 is where I think I ended up at. I think 350 on this pass, and then when I came through with Dovetail cutter, I let that clean the floor up a little bit by a couple thousandths. Not really impressed with this depth mic that I have. It's a little. I've had it apart a couple times trying to figure out why it's so gummy, but it's really gummy. Doesn't move very well. You can't really feel the feel when it touches. So I think that's not something I'm gonna get rid of. It's got a lot of sentimental value, but something I'm probably gonna replace here soon. So here we are starting to do the side cutting. I'm dialing in about 100 thousandths depth of cut to the side on each pass. So this will take us a couple passes to get through. And it's possible I might have put these in at 200 thousandths. It does kind of look a little thicker. I guess if we had the original audio, I would have set it, because that's how I do my audio in these kinds of videos. Is I try to at least tell the camera what I'm doing, so even if you guys don't hear it, I'm telling myself as I'm reviewing it and editing. So the other thing to note here is I'm using compressed air to clean off the tool. I know some people kind of frown on that because it can push chips into the ways and such, but we got good weight covers on this. The vise is up above quite high, and you can see I just push all of the chips into the corner. I've cleaned that about once a year. They just naturally go there anyway, so I just use the compressed air to push them there. So here we are making dialing in on our finished cut. You can see I'm measuring there, trying to get to our 660 mark here. You can also see the 3D print that I used for the test fits. I will say those 3D prints came out to about less than a thousandth of an inch on my good calipers from what I set the print to. On a part like this, I like to take 3 measurements down the length and just take the average of them. This mill does cut less than a thousandth out at 6 inches. I did a lot of tram work on it before I cleaned this piece up to make it parallel and square. So right now the mill is in good shape. Like I said, less than a thousandth of an inch end to end across that 6-inch piece. So I'm pretty happy with those results. Once I get my measurements dialed in on this side, I move over to the other side and start matching those the measurements that I had. If you might remember from the drawing, 1.805 is that inside measurement we're looking for. So I don't care about the thickness of this part on this end. Everything is driven from that far right corner, the furthest away from us. So if you remember on the drawing, I said I had those dimensions at the bottom to help me with machining, and that was because I planned on dialing in that corner on the DRO and making all my cuts based on that. I don't know if this comes off, but I'm not a professional machinist. This is a hobby for me. I enjoy doing this kind of work. On my day job, I definitely don't get to have very much hands-on. So one thing I'm showing here is something that I like to do with my tools, which is put the covers on them where they have a sleeve or a plastic cover when I'm putting them on and taking them off the mill, because with this R8 tapered collets, you have to tap the top of the drawbar in order to get the tool to release. So I'd rather have those plastic covers on and protect the tools from chipping, or even more so, protect my hands from getting cut. When I first started machining on this mill, I got quite a few little scratches where I just bumped the cutters. So now that we got the dovetail cutter loaded up, I zeroed out the dovetail cutter on the actual surfaces, so I zeroed them out on those inside surfaces 1.805 apart from each other, and then used the drawing to mill in the distance that I had specified. This will end up being a little tight, but we'll talk about that a little bit later. This cutter I run pretty slow, so at least on the feed rates. You can see here I'm doing the measuring between pins process. There's an online calculator. I'll put a picture and a link to that at the end of the video in case you're interested. But Google dovetail measurement calculator, and a lot of them will show you the process for doing over the pins. So here we are with our first look at my lathe. It's probably been in some other videos at some point, but this is the first time in this modern series showing it. You can see that everything looks really good. The depth of the floor there is really nice between the male and the female parts. I decided that I wasn't going to take that all the way out, the extra 50 thousandths. I liked where it sat, so that's where I left it. Now we get a nice view of my hands, blocking the view of me trying to insert the gib into the right hand side there. You can see I can get just the tip of the gib in there, and only the tip. So at this point, I'm making a decision about what I'd like to do. A couple things I'm looking at is this distance from the left-hand side. So if you remember, flipped over, that was where our 660 measurement was on the bottom side of that dovetail. The reason why that was so important is I was trying to make it so the saddle would just hang over just a little bit past the side of the saddle. So here we are back at the mill. We're just doing a quick cleanup cut. I believe I ended up taking a total of about 15 thousandths off of this between the two sides. I believe it was 10 on one side and 5 on the other. One, to pull that saddle in a little bit because it was overhanging just a tad bit more than what I really like. So I took another, I think 5 thousandths from that side. Now we're going to go back and do a test fit, and this will be our final test fit for this portion of the machining. So we're going to slide the saddle blank here on from the back. Again, nice solid fit, and here we're going to slide the gib in. The gib is directional, so you do have to pay attention to which way you put it in. It's got some indentations for the set screws that I'll have to match on this new part. This is the original gib, but it's in fairly good shape. Needs to be stoned a little bit, but it should be fine. You can see here I'm trying to twist the cross slide on the saddle, and honestly, this has turned out to be a really great fit. I don't feel any movement. Once we have a tool post on, we can maybe refine a little bit, get a test indicator on there and see how much lift we're getting on the right hand side, since that's actually what happens. It tries to pull the cross slide counterclockwise on the saddle. This does fit under my small 3-inch micro chuck. I don't think it'll fit under my 4-inch chuck, but that's all right. Rarely do you actually need to put the saddle all the way underneath the chuck in order to make clearance or room. The really important thing here is just making sure you can get the tailstock close enough to the saddle to do any tailstock work on your part. Next quick thing we're going to do is just measure our center line. Rough measurement, this doesn't matter at this point. We just need to know roughly where it is from the top of the saddle. I left a lot of meat on the top of this knowing that I would thin this out later. And so here I'm deciding how much meat I'm going to leave on the female part of the cross slide above the female part of the cross slide to the top of the cross slide. I think I eventually settled on a 1/2 inch of material there. So we're going to end up machining about a 1/4 inch off the top of this. So let's go back to the mill and get that started. So back here at the mill, I've got my 5-flute face mill installed in the mill. Again, we're going to use the paper trick here to find the top of the part. Again, we know that the paper is 12 thousandths. Once the cutter pulls that out, we can reasonably believe we're 12 thousandths away, and it allows me to use the fine dial feed on the quill to come down and zero in on the part. I probably still need a little more practice doing this particular trick, and I know some people can get this really accurate. I've also heard of using feeler gauges and bringing the cutter down and touching a feeler gauge. I've tried that. I don't think it's any more accurate than the paper trick, so it's not worth getting the feeler gauge out. So anyway, coming down, we're going to touch off here, and then I'm going to dial in what I think to be 100 thousandths per cut on this. End up taking about 200 thousandths in the end, using the face mill, and then unfortunately we lost the footage, but I did come back and cut this with a fly cutter. So right here at the end of the episode, we'll see the results of those cuts. So a little bit of oil here, and we're gonna go ahead and send the cutter in. I actually stalled the cutter out here. Unfortunately, it had a little too much surface speed, so I backed that off on the power feed and set everything back up and sent it again. And this time it looks much happier. Hey look, I removed that handle that was been annoying all of us throughout this entire video. I love how it just peeled that chip off the side, but that's not usually how I like to mill. I like to have a little bit of overlap so we don't leave a hard chip on the side of the piece. And one thing you notice here is I'm coming back and cutting the exact same direction from the exact same side. The reason is that this face mill throws a rooster tail of chips, and I like it to throw that rooster tail of chips out towards the back of the mill versus into my face. So I find that little just rapiding back and cutting back from the same side is much more enjoyable for me as a craftsman than the alternative of having to wear a face shield and getting plastered with chips every time I run the cutter back the wrong way. Here we are starting our second pass. Again, I believe this was again 100 thousandths depth of cut. And if any of you are wondering, the final dimension that I ended up with from the bottom of the cross slide to the top of the piece, it ended up to be 0.852. So if you remember, I said we had about 352 thou from the bottom of the cross slide up to the floor of the dovetail, and then I left 500 thousandths, almost dead ringer above that. So, and now let's look at the results. The end of this part for this episode. We've got the dovetail cut. We've got this great finish on the top from the fly cutter. I run that with a very, very slow feed with a solid depth of cut. I actually run my fly cutter, it seems to really like a 5 thousandths depth of cut. So, you know, anything 5 and above, but you want to start taking off single thousandths, it really doesn't cut as well. Here's the dovetail measurement calculator that I used. You can look the formulas up for this and do it by hand as well, but I really appreciated the fact that these fine folks put this calculator up here, and this is what I used to develop my CAD drawing. So feel free to check it out. You got a few measurements you're going to need to fill in. You can see, you can take the measurement over the pins from the male, and that will give you the measurements that you need to make for the female part of the part. So here we are, one last look at the drawing. Again, we changed a few measurements, like the 401, we changed to 352. We took out those reliefs and didn't cut those in. But this was all close enough to get me to the point where I could dial this cut in really well and get the fit just where I wanted it. So thank you again for joining in. If you want to send me a note or let me know what you think, that would be great. Post your comments in the section below. And of course, like and subscribe and all that good stuff. But hey guys, I'm just here making content. I'm doing this thing anyway. And I thought I'd just bring all of you along for the ride. So I hope you enjoy it. Thanks for watching. We'll see you next time.